Imagine waking up one morning completely shocked by a soaring electricity bill as the scorching summer kicks in. But for the Amish, that bill is practically zero thanks to a $300 underground pipe system they use to cool their homes. The idea is not magic. It is not a secret machine. It is a simple building science principle. Use the Earth's thermal stability to pre-cool air or to reduce the heat load before your mechanical system has to work so hard. So why don't builders install this under every new home? Because the physics is the easy part. The hard part is moisture, mold, radon, drainage inspection, liability, and building codes that were not written for a buried air path feeding a modern house. Builders do not reject it because the ground stopped working. They reject it because one bad installation can turn a clever cooling idea into an indoor air problem. And that is where the real story begins. Before we dive into the details, please take a second to hit the like button and subscribe to the channel. Every little action from you is a huge motivation for our team. The reason this works begins with a simple difference between air and earth. Air reacts fast. A driveway can heat up in one afternoon. A roof can become painfully hot before lunch. An attic can turn into a trapped heat chamber while the living room below is still trying to stay comfortable. That is why your air conditioner is always chasing the weather. The target keeps moving. The ground does not behave that way. Soil has mass. It has weight. It holds heat slowly and gives it back slowly. Air is like a thin blanket. It warms quickly and cools quickly. The ground is more like a giant thermal bank. It does not react by the hour. It reacts by the season. That delay is called thermal lag, and it is one of the oldest cooling principles in building science. When summer heat strikes the surface, it does not instantly reach the deeper layers of Earth. It moves downward slowly. By the time that heat has pushed deeper into the ground, the hottest part of the season may already be passing. That is why basements, root cellars, and shaded crawl spaces often feel cooler than the air outside. They are not creating cold, they are borrowing stability from the Earth. An earth tube uses that same idea in a controlled way. Warm outside air enters a buried pipe. As that air travels through the pipe, it gives up part of its heat to the cooler soil around it. The longer the path, the better the contact. The slower the air moves, the more time it has to exchange heat. But this is where many viral claims become misleading. Ground temperature and room temperature are not the same thing. Between those two numbers is design. The air coming out of the pipe depends on pipe length, burial depth, airflow speed, soil type, soil moisture, groundwater pipe material, and condensation control. In the right conditions, this system can pre-cool incoming air and reduce the load on mechanical cooling. It should not be described as a guaranteed way to make every home cold. If the principle is this simple, why is it not sitting under every suburb in America? The answer begins with the way older communities, including the Amish, understood climate before machines became the default. The Amish did not need to invent modern earth tubes to understand the principle behind them. Their real advantage was simpler, and in many ways, harder to copy. They paid attention. Before a machine was chosen, the land was studied. Where does the wind move? Where does shade fall in the afternoon? Where does water stay cool? Where does the soil hold a steady temperature? That way of thinking is almost invisible in modern housing, because most homes are designed around equipment first and climate second. A root cellar is the clearest example. It does not cool food because it has a hidden device inside. It works because the earth around it slows temperature change. The soil becomes a protective shell. It softens summer heat and winter cold. A spring house follows the same logic. Cool groundwater moves through or beneath the small structure, helping preserve food without depending on a compressor. Traditional farmhouses use deep porches, shade trees, cross-ventilation basements, and heavy materials for the same reason. Each feature reduced the amount of mechanical help the house needed. That is the real lesson. The Amish cooling tunnel should not be treated as a buried secret or a miracle trick. It is part of a larger way of building where the house cooperates with the site before it asks for electricity. Modern construction often reverses that order. It builds fast seals, tight installs machines, and lets the homeowner pay for comfort later. The question is not whether old communities were smarter than modern engineers. The question is whether modern housing forgot a layer of intelligence that used to come before engineering. If a community with limited dependence on central air can use earth, water, shade, and airflow to manage heat, maybe the problem is not that America lacks technology. Maybe the problem is that many homes were never taught to read the climate around them. Physics can be correct, and the installation can still be wrong. A home system does not only need to move heat, it has to stay clean, safe, inspectable, maintainable, and friendly to indoor air quality. That is why nobody should dig a deep trench drill through a foundation cut into an HVAC system or bring underground air into a house without local code review and qualified design help. The ground can help you, but the ground can also bring problems into the home if the system is careless. The first problem is condensation. When warm, humid air enters, a cooler, buried pipe moisture can form on the pipe wall. If that pipe has low spots, poor slope, or no drain point, water can sit there. Standing water inside a dark pipe is not a green building solution. It is a maintenance warning. The second problem is mold. A buried air tube can be dark, dusty, damp, and hard to clean. If the pipe is corrugated, moisture and debris can collect in the ridges. If there is no clean-out access, the homeowner may not know what is happening inside that tunnel for years. The third problem is radon and soil gas. Some regions have higher radon risk than others. Pulling air through an underground pathway without testing the site can turn a cooling idea into an indoor air concern. The fourth problem is simpler but still real: insects, rodents, leaves, rainwater, dust, and earthy odors. An outdoor intake needs screening, filtration, drainage protection, and regular maintenance. This is why the smarter conversation separates open-air earth tubes from closed-loop ground loops. An open-air tube moves outdoor air through buried pipe and into the home. A closed-loop system moves liquid through a sealed loop underground, then transfers temperature through a heat exchanger or fan coil. If the open-air earth tube is the folk version, the closed-loop ground loop is the version modern building science can trust more. And that $300 number, it may cover basic parts for a small experiment. It does not cover excavation, drainage, radon testing, foundation work, labor permits, or professional design. If someone says $300 can replace your whole air conditioner, ask what they quietly left out. This system is not banned because one national law says every American homeowner is forbidden to use earth tubes. It is banned in a quieter, more practical way. In many places, nobody knows exactly how to approve it, who should inspect it, who carries the liability, or how to verify long-term indoor air safety if the system is built wrong. Modern homes are inspected through familiar categories: ductwork, HVAC equipment, drainage, plumbing foundation, and ventilation. A buried air pathway sits between all of them. It touches the ground like drainage. It moves air like HVAC. It enters the home like ventilation. It can affect moisture like building envelope design. That makes inspectors cautious, and caution usually means rejection, unless the drawings, materials, drainage, filtration, radon control, and maintenance plan are clear. Builders have the same problem. A standard air conditioner comes with a manufacturer, manual warranty, service network, and replacement parts. A failed earth tube creates a harder question. Who is responsible? The designer, the excavator, the HVAC contractor, or the homeowner? That is why this idea disappeared from mainstream housing. Not because the earth stopped working. It disappeared because modern construction is built to sell equipment, standardize labor, and reduce liability, not to read the climate of each individual site. The Amish cooling tunnel is not a miracle. It is a reminder. Before buying more machines, people once used soil, water shade, and thermal lag to make life more comfortable. Comment your state, your summer cooling bill, and whether your home has a basement crawl space or enough yard for a ground loop. Some places make sense, some places do not.